All right. So, hello and welcome back to this particular lecture on process camera. So, I think by the time you will watch this lecture, this you will already have a fair bit of idea about why process camera is being used in graphic reproduction. What is the purpose? What are the functions? How to operate? And all these things, some basic fundamental ideas you already should be having, because the way I have ordered the lectures is such that first you will have some basic idea about film development, film chemistry, film photography, then half-tone reproduction, and related to half-tone reproduction, there I have already mentioned a lot actually regarding the process camera. Okay, so after developing that idea, after developing that basic overview on why a camera process camera is used, in which circumstances, what is the purpose of using such a equipment, uh, only after that you will be able to understand and fully appreciate the process camera in its entirety, and hopefully this video lecture will help you develop a better functional understanding of the operational procedures of the process camera that we have. So this lecture has been developed jointly by myself, Shankhu Debnath, lecturer in printing technology, Regional Institute of Printing Technology, and Mr. Rupak Dash, who is a faculty member in the Department of Printing Technology, Regional Institute of Printing Technology. In the end, you will also find a video which has been developed, and in the video definitely will be also seeing Mr. Ujjwal Maji, who is another faculty member in the Department of Printing Technology, Regional Institute of Printing Technology, Kolkata. So, without further ado, let us now take a look at what the process camera is all about. All right. So, as you already know, that the purpose of the process camera is to prepare a graphic material, and before the invention or before the use of color scanners, process camera were used by operators to create transparencies that were used for the preparation of image carriers as plates for offset printing. It was both grayscale transparencies as well as color transparencies. Color transparencies is already known. So these process cameras, in the construction wise, they came into two categories. They could be classified into two categories. The first one is your gallery camera, and the second one is your darkroom camera. So what is the difference between the two? The difference in the darkroom camera is that they the main component, one of the chief components of such a camera was the darkroom in itself. So the you could not separate the camera from the darkroom as such. So in your but in contrast to your gallery type of camera, they are independent of such darkrooms, and only the after the transparency has been exposed through the proper methodology, then you take out the transparency, and you go to the development room that is known as the dark room for the development of that photographic transparency. So that is the basic difference between the two. And as you can see, it was also written that light proof holder for the sensitive material that must be transported between the camera and darkroom for loading, exposing and unloading. So they are two different, you can say, two different spaces. So darkroom as well as the gallery camera are two independent of each other. One has to carry that exposed transparency that has been exposed by the camera into the darkroom for further processing. That is the primary difference between the gallery and the darkroom camera. Okay, now let us see what else we have got to see over here in this particular video. So based on the construction type, also how the copy board as well as the film board are arranged, you can see that they are divided basically into two types. One is your horizontal process camera and the second is your vertical process camera. The one that we have in our lab, that you have already worked in your first year's repro photographic lab, that is basically a horizontal process camera. Now, why is it known as a horizontal process camera? You see, this is basically the principal schematic that you see in front of you that has been provided over here. So what is the construction of a horizontal process camera? Here, the copy board, which you can see on the right hand side, is parallel to the focal plane, that is the also known as the film board, but their arrangement are in horizontal formation, right? So they are arranged in a horizontal plane. You can see there is a single plane on which the copy board, the focal plane, as well as the aperture definitely of the camera system, they all lie on that single horizontal plane. That is why they are known as the horizontal process camera. As you already know, I have already explained in a lot of detail in my video lectures that you have already listened by now, that the nature of the copy board is such that it is the place, you can say it is basically the placeholder for the original. So if you are working with a reflective type of original, then you have to illuminate it with a 45-degree angle. That means you have to, the light which is incident on the original will get reflected off of that surface, that is the reflection copy, and will enter into the transparency which is placed in the focal plane through the lens aperture after getting reflected from the copy board itself. However, if you are using a transparency as the original, then you have to illuminate it from the back of the copy board, right? So that it may transmit light. The transmitted light is, passing through the camera lens aperture and entering into the focal plane. All right. And finally, this is how the film exposure process takes place in your horizontal process camera. Okay. So now let us see what else is there. This is the another typical construction of the horizontal process camera. There is so this is basically your copy board that you can see in front of you. This one is basically your copy board that you can see in front of you. This is where the original is to be placed. Here, as you can see, this is the lens, or you can see it is the lens aperture rather. And finally, this is the focusing plane on which the transparency is to be placed, which is placed behind in front of the ground glass. And this extension that you can see, this flappable material that you can see in front of you, this is known as the bellow. Now you already know by now why a bellow is required. If you remember our penumbral theory of half-tone photography and how we calculated the screen distance with the help of the penumbral theory, we all saw what is the value of the V ratio, right? And what is its relationship, how it comes from, how you can draw an analogy with the F number, right? So that is why this bellow is basically determining the focal length. Why focal length is important? Hopefully that you already know, because if focal length is not maintained, then the image will not, or the light will not fall into the focus of the optical system, and we will not be able to get the sharpest image quality. So you already know how to calculate the screen distance using penumbral theory, using diffraction theory, as well as the visual method, right? So I have already given a lot of lectures in that area also. So let us see what else, what other components. And this is the plane actually on which all the components are laid, because this plane is actually horizontal. That is why it is known as the horizontal process camera. Right. And so illuminants are placed over here, so that if it's a reflection copy, such illuminants may be placed, right? And this is, as you can see in front of you, this is the vertical process camera. Now why it is known as the vertical process camera? As you can see in front of you, this is the the copy board, this is the bellow system. Here the middle of this, there is the lens aperture, and this is where you place the, above, behind this actually you place the transparency which is to be imaged. Now you see, how are they arranged with respect to each other? They are arranged vertically on top of one another. That is why this is known, this type of a camera system is known as the vertical process camera. Okay, so like in the earlier case also where we saw that the components were placed horizontally with respect to each other, but here it is we see that it is placed vertically on top of each other. That is why they are known as the vertical process camera. Okay, as and normally everything as you had seen in the horizontal process camera also, that is present over here. This is another picture, a bigger picture, as you can see, that you can see in front of you. This will give you a better idea. This is again the copy board, the lens, the bellow system. This is the focusing glass and where the film is to be loaded. Now let us talk a little bit in depth about the different types of components that are present in the process camera. Copy board, hopefully you all know. The lens also, the function of the lens is to to focus the light rays so that the sharp image may be obtained onto the transparency. So depending upon the optical system, the lens system is being manipulated, and we can change the focal length also by manipulating the bellow, by changing the camera so-called camera extension as such, right? So these are the two important concepts there. And next we have the bellow, which is I've already explained earlier also, and then the ground glass, which is required for checking whether the focus and the placement of the copy that is to be photographed is placed correctly or not, and the image is forming sharply or not. Such visual checks are being done with the help of the ground glass. And bellow, as I already mentioned, is used for changing the focal length, the camera extension, in order to get the appropriate screen distance, right? Now in this here, I would also like to talk a little bit about the camera image reversal and correction system. Normally, if you are using a normal optical system only containing lens, various combination of lens, there is a chance, and of course if there will be some reflex mirror, these type of optical systems, they tend to laterally reverse. Even when like you see yourself in front of a mirror, you see that your left has become the right in the virtual image that you see in front of the mirror. So this is known as lateral reversal. Okay, so then if this happens, this is not wanted. We want that there is laterally correct images in our image, in our transparency also, from which we are going to make plates finally to print, right? So in order to do that, our camera has this system, that it has got this prism lens system, which helps not only to focus the image correctly onto the the transparency, but it provides another important it performs another important role in, you can say, having the purpose of laterally correcting your image. If you see over here, when we only had this type of lens, single lens system, or even a combination of lens, there is this laterally reverse image is formed. But because of the presence of the prism and the way it refracts lights, the ultimate resultant image that we see in front of us, that when the image is forming to the transparency, that image is becoming laterally correct. So you see, this is basically the method using which we laterally correct the images which were previously reversed. So this type of optical systems are also incorporated in the process camera, and this can be manipulated. This were actually manipulated earlier in order to get accurate images. Now it is another important concept is there, that is known as the dark room. So what is the purpose of the dark room? As I already mentioned earlier also, that when you are talking about gallery type cameras, you have to physically take out the exposed film where the latent image has been formed, and you have to take it to your processing department, which is referred to as the dark room. Now the dark room is not always completely dark, but depending upon the film that you are using, so by this time you already know what type of light sensitivity is there in the panchromatic film, what kind of light sensitivity there is in the orthochromatic film, all these things you know. So depending on the type of film that you are using, if you are, for example, if you are using a panchromatic film, what does pan mean? Pan means all. That means your film is the light sensitive to all wavelengths of light. So in that situation, you are not able to expose the film even in the dark room, so you have to work in complete darkness. But if you're using a orthochromatic film which is sensitive to blue green light, then you can use a red light to which the film is not sensitive to, and hence it can be accomplished, your processing work can be accomplished. So depending on that, that is why we process the film in such rooms which are containing either selective or no light at all. That is the purpose of the dark room, where we can do this processing work with our films actually. Now, another very important concept, this also I have explained in our previous lectures also, when I was starting my lectures in half-tone photography, because as you know that in order to get a fair bit of concept of masking, photographic masking, and how that is done, the photographic masking ranges, that is the AM range, MB range, the highlight contrast, shadow contrast, and all these concepts are very much related to, if you will not be able to understand these concepts until and unless you have a fair bit of idea about your what is a negative and a positive. So as you can see over here on the, I will start with the negative actually, okay, because many a times we prepare negatives, and our conventional processes like the Egalbumin process that I think you are all acquainted with is a negative working plate. That means you are preparing a negative and you are taking that negative, you are not converting it into a positive, and just taking the negative and exposing the plate using that negative in order to get the final plate. So that is, different types of plates are there depending upon what type of transparency you are using. So negative is the image where there will be silver deposition after development. There will be silver deposition in the non-image area. So this dark color that you see, this is actually a non-image area. But you will say, sir, why there is this black, why it is represented by this black thing, that is silver deposition here? Because it is a negative. Since it is a negative, that means we are, so what actually happens, so just although you, I think already you know this concept, but again I am just giving a very brief idea over here. Now see, if you will expose your Egalbumin plate using this particular negative, what will happen? Which areas in the plate will receive light? Think about it, very easy. That is, the actual image area in the plate is going to receive the light. So after receiving the light, then the those chromic oxides, there are in the emulsion layer, that will form into chromates, and as a result of which they will get hardened, and the non-image area which does not receive any amount of light, these particular areas will remain unhardened in the plate, and during the washing and development process, that unhardened non-image area will get washed off. So you, after development, what you do is basically you apply this lacquer and the ink, so as to ensure that the ink is falling right onto the image area, and you also desensitize simultaneously. In order to desensitize, I have already explained this in the colloids class and the PMS class also. Desensitization used with the help of the using of gamma Arabic solution, so that the non-image area becomes water receptive and it hates, or it repels kind of the ink. So that is how the negative working plates are made. So now you understand why this is known as the negative, because the silver deposition has been obtained in the non-image area. That means these dark areas in this particular image are the non-image areas in the negative. So naturally, just the reverse will happen in the positive creation. That means the image in the silver deposition, metallic silver deposition after development will occur in the image area, and the non-image area will be devoid of any silver halide deposition. That means there will be silver deposition. Sorry, that means there will be unexposed silver halide in the non-image area, and during the development of the plate, we can definitely very easily wash out or wash off that particular unexposed silver halide material from the non-image area. So this is the difference between the positive transparency and the negative transparency. Okay, so all those things have specific purposes. Now let us talk a little bit about the automatic film processes. You have already done these labs of development of the film in the first year, right? Now although you have done this in a manual way, That means you first put it in the tray, you developed it, then washed it, then added to the stop bath solution and all this. However, in case of your automatic film processors, what happens? There are machines. Okay, there are machines where there is successive rollers. Okay, successive rollers. These rollers force the you can say exposed film onto themselves, and there are development chemicals in different chambers. So there is the first development chemical, then there will be the other accelerators and other materials which goes into the making of the film development process, and finally there another tank will contain the stop bath to prevent any further development, so that overexposure and all these problems are not done. So these type of machines are known as automatic film processors. What is the advantage? Advantages are manifold. You see, when you are doing it manually, all right, that means you are determining the bath time or the development time. You are determining which areas are getting developed by determining how to adjust the film into the development bath. So it is completely manual. There is no control or steady control over the film. Of course, experienced film developers, definitely they have good control. However, it is very difficult to achieve control in manual process. But if you do it automatically using an automatic film processor, then that kind of brings or enhances the productivity of the process, and definitely you can say the health risks that are associated. So for example, if you are working with metol, hydroquinone, these are all aromatic compounds. Hydroquinone is an aromatic compound, so it is not always good for health. I mean, not always, no, it is not good for health. So prolonged exposures to aromatic compounds are poses a health risk. So in order to avoid any such health risk and any form of further difficulties that is obtained by the film maker during the development process, these machines were created with the aim that the entire process of development would be automated, right? So let us take a look at one of the the structure or the overview of one such development machine. You can see in the given image that will come in a bit actually, there you will find out successive rollers, as I just mentioned, this one, and each of the rollers stacks is associated with a tank. So this is basically your the development tank, then the fixing tank, then the stop bath tank. So all these, what happens, you insert the roller through this end, and ultimately what happens, these rollers are also placed in these tanks, individual tanks, and these rollers, when they rotate, so if imagine there are two successive rollers and you insert a film out of it and they are rotating, what will happen? They will pull the film from the receiving end, and that is the feeding end, and it will take it ahead. And within where is the roller kept? The roller is kept in the tank. So what is kept in the tank? These development agents, these fixing agents, these stop bath agents, these acids, all these things are kept. So what is happening? The rollers are taking the film forward. As a result of it, there is constant rinsing of the film with these chemicals, as a result of which the exposed film where the latent image was formed, the ionic silver gets converted or gets reduced to metallic silver due to the action of these developing agents, and as a result of which finally when it comes out, the final or actual image is formed onto the film. So this will actually come out, and there is a whole lot of advantage that I already mentioned in this particular process. Okay, now this is a small quiz kind of for you, that which of these, A or B, which of this is a automatic film processor? So I will not be giving the answer to this question. You find out which of this is the automatic film processor, and of course your work does not stop only by identifying which is the automatic film processor. Also you have to identify the other thing, which is there are two images, A and B. What is A and what is B? So I have asked you which is the automatic film processor, but you should also not only answer that question but also go ahead proactively to answer or identify the other image also that is being given over in this picture. I hope you will be finding this small exercise interesting. Now this I think this it will be relatively easier for you to answer, because one of these you have already seen. So I will not say where you have seen this, but the question here is, out of A and B, which is the vertical process camera? I think this will be, you will be definitely able to answer this question. This also, the answers I will not be discussing in this lecture. You write it to me in my Google Classroom platform. I'll be seeing the answers that you give. But again, like in the previous slide, you do not only have to identify which one is the vertical process camera, but you also have to identify which is the other thing that is present over here. I think you will be also be able to answer this question. Okay, so now what we will do is, I will stop talking. I will stop my lecture here. But let us take a look at a very nice short film that has been developed by our respected faculty members in the department. There are other retired faculty members also that you will be seeing in the film. We are extremely thankful to all of them that they have worked so hard to make this film, and ultimately you see that in this short film you will get a very good idea about what to expect while working in the process camera. I think you will be able to hear the audio also. So step by step, all the processes and what is the purpose, everything has been mentioned very beautifully. So I will request you to, now I will stop speaking and you please watch this short film, and thereafter we will be ending this lecture. Okay, let us see.
Camera department. Variety of cameras are available. Vertical camera, gallery type camera, darkroom camera, etc. Whatever may be the type, the basic working principle is the same. Let us study this camera. This is copyboard where the original artwork is set. These are the lights for illumination, the lens, and the viewfinder for adjusting focus and position of object. This is the dark slide loaded with film in darkroom and inserted in camera. To obtain the negative, exposure is given for stipulated time, and the dark slide along with the film is brought to the darkroom and developed. After this, if necessary, retouching may be done to get a finished negative. This finished negative, or sometimes a film positive, is used for making the image